Hello students, let us continue with chapter 1 of your books, Number Systems, and today's topic for discussion will be operation on real numbers. Now before we proceed with the operations on real numbers, let us see the different laws that we already studied in the 8th grade. I am sure you must be familiar with commutative, associative, and distributive laws. We will take a look at these laws, okay, but you had studied in your 8th grade that when rational numbers satisfy these 3 laws for addition and multiplication, right. So, let us see what these laws are. So, when I take the first one, commutative, suppose I have a number a plus b, it can be written as b plus a. So, this is for the addition. How about multiplication? I have a into b, this can be written as b into a, where both a and b are rational numbers. Let us take examples of actual numbers. Suppose I write 2 plus 3, it can also be written as 3 plus 2. Similarly, for multiplication, if I have 3 into 2, this can be written as 2 into 3. So, this is my commutative law. Right? How about associative law? So, associative law suggests if I have a plus b plus c, where b and c are in brackets, this is also equal to a plus b plus c. A plus b into brackets plus c. Similarly, for multiplication, if I have a into b into c, this is also equal to a into b into brackets into c. Let us see this for numbers. So, if I take 2 plus 3 plus 5, I get, this can also be written as 2 plus 3 plus 5. So, when you add, see, this is going to give you 2 plus 8, which is 10, again 5 plus 5, which is 10. Similarly, if I take 2 into 3 into 5, it is equal to 2 into 3 into 5. So, this is going to be 2 into 15, which is 30, and 2 into 3, which is 6, 6 5s are 30. So, associative law is applicable for your rational numbers. How about distributive? So, distributive law suggests a into b plus c is equal to a into b plus a into c. Where you are multiplying, this is nothing but a multiplication sign. Okay, if you can even leave it out and leave it as a brackets b plus c, which means that a is getting multiplied with b, then you have the plus operator and a is multiplied by c. Okay. So, let us take an example. If I have 2 into 3 plus 5, this is equal to 2 into 3 plus 2 into 5. Let us check the left hand side. This is going to be 2 into 8, which is 16. How about this? 2 into 3, 6 plus 10, which is also 16, right? This is 16 and this is also 16. 2 8s are 16. Therefore, rational numbers satisfy all your commutative, associative and distributive laws for addition and multiplication. Now, you see, you have used rational numbers here. What is the output? The output here was 5, which is a rational number. The output here was 5, which is again a rational number. The output here was 2 plus 3 plus 5, which is 10. So, 10 here, and 2 into 3, 3 5s are 15, 15 to 2, 30. Again 30 is a rational number. So, in each of these cases, look at the outputs 5, 5, 10, 30 and 16. They are all rational numbers. So, when you are applying commutative, associative and distributive laws, for addition and multiplication, the output is going to be a rational number. Also for rational numbers, see, we have just mentioned plus and multiplication, that is addition and multiplication. But even if you use operators such as, the remaining two operators are subtraction and division. So if you are performing these two functions, these two operations, that is subtraction and division, on rational numbers, the output is going to be a rational number. Okay, but these three laws, that is commutative, associative and distributive laws, are not really applicable for these two operations. How about irrational numbers? Let us first just write a conclusion for rational numbers. So operations such as multiplication, division, addition and subtraction on rational numbers the output will be a rational number. So this was about rational numbers. How about irrational numbers? In case of irrational numbers, if you are using these four signs, then the output may or may not be an irrational number. So it could be either a rational number or an irrational number. So this was for rational numbers. Rational numbers are denoted by Q, which is why I have written Q. This multiplication, division, addition and subtraction on irrational numbers may give the output as a rational or irrational number. So what we'll do now is we'll just draw a table wherein I will take two rational numbers, two irrational numbers and a combination of rational and irrational numbers, and then we'll see what our outputs are for the different signs, which is multiplication, division, addition and subtraction. Okay, so let me just quickly draw the table for you. I have rational and rational. Then I will take irrational and irrational. And finally, I am going to take rational and irrational. So let us take the first sign, which is, say, addition. So we've seen for rational numbers the output is always going to be rational. However, let's just check. So if I take 2 plus 2, I am going to get 4. Okay. If I take 2 plus minus 2, it is going to give me 0. This is a rational number. 0 is a rational number, 4 is a rational number. If I take something like 5 plus minus 2, it's going to give me 3. And even if I take minus 2 plus 5, it is going to give me, 2 plus of minus 5, it's going to give me a minus 3. So all these numbers 4, 0, 3 and minus 3, they are rational numbers. Now let's check this for subtraction. So for subtraction, if I take 2 minus 2, it is giving me 0, which is a rational number. If I take 5 minus 2, it is going to give me 3, which is a rational number. If I take 2 minus 5, which is equal to minus 3, this again is a rational number. How about multiplication? So I take 2 into 2, it's giving me 4. 4 is a rational number. Similarly, 2 into minus 10 is giving me minus 20. Similarly, minus 2 into minus 10, it's going to give me 20. So 4, minus 20 and 20 are all rational numbers. How about division? So division is denoted by this or this. If I take 2 upon 4, it will give me 1 upon 2. Similarly, if I take 4 upon 2, it will give me 2. And if I take, say, 1 upon 3, it will give me 0.3333 dot 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 or 0.3 bar, which we saw in the previous classes that 0.3 bar is a rational number. Why? Because it is a recurring decimal expansion of your rational number. So all these are rational numbers. So the output for a rational and rational numbers for these signs is always going to be rational. Let's take a look at irrational and irrational. So for irrational, first we will take addition. So if I take root 2 plus minus of root 2, this is going to give me 0. Now 0 is a rational number. What if I take root 2 plus root 5? Now just note that you cannot do this as root 2 plus 5. It is wrong. Okay? This is wrong. Why? Because root 2 you can say it's an apple and root 5 is a banana. So you can't really add an apple and a banana. So the output here, if you see, is root 2 plus root 5 itself. So both of these are irrational numbers, therefore the output is going to be irrational. So did you notice that we have a combination of a rational number and an irrational number? So irrational and irrational would give you a rational number or an irrational number. How about subtraction? So if I take, for example, root 2 minus root 2, it is again going to give me 0. So again we have a rational number, and if I take something like root 5 minus root 2, both these terms are irrational, so my output is going to be irrational. Again I have got a combination of a rational and an irrational number. Now if I take, this was for subtraction, I will just write it a little here in this line, so it becomes more evident. So root 2 minus root 2 is giving me 0, root 5 minus root 2, these both cannot be subtracted as the under root of 5 minus 2 because they are two different terms. So this is the output here is going to be irrational. How about multiplication? So let's say I take root 2 into root 5. It is giving me root 10. This is nothing but equal to root of 2 into 5, which is root 10. So you see, for addition and subtraction you cannot combine these two terms, but for multiplication and also in division you will see that you can combine this under one root sign. Okay, so this is root 10, but how about root 2 into root 2? This is going to give me 2. So 2 is my rational number. Again if I take another example, let's say root 2 into minus of root 2. So this is going to be, minus stays outside, I have root 2 into 2, which is going to be minus of 2, right? It will be minus of root 4, which is 2. So again I got a rational number, minus 2 is a rational number. Let's check for division. Let's say I take root 4 divided by root 4. What do I get? This will be equal to root of 4 upon 4. So 4 ones are 4 and 4 ones are 4, which is going to give me 1. 1 is my rational number. But what if I take root 4 divide by root 2? I get root 4 upon 2, which is 2 ones are 2, 2 twos are 4. So this is going to give me root 2, which is an irrational number. If I take something like root 4 divide by root 3, this is going to be root 4 upon 3. So this 4 is the square of 2. So 2 will come outside on the numerator. I get 2 upon root 3. So this is a combination of a rational number in your numerator and irrational number in your denominator, which is why this entire term becomes irrational. So we see that for irrational numbers, these different operations are going to give you either a rational number or an irrational number. Let us check for rational and this was for irrational number. So combination of irrational and irrational may give you an irrational or a rational number. So here you get a combination of rational and irrational. So please take a look at this, because I am going to erase this side since I am running out of space over here. But I hope you have got a clear picture of what outputs we are going to get for rational, irrational, irrational. Now let us take a look at rational and irrational. I am erasing this side. So I am going to take rational and irrational numbers. Now for addition. So if I take 2 as my rational number and root 2 as my irrational number, you can't add them because this is apple again and this is banana. So you leave it as it is. But what if I get root 2 plus root 2? This will be equal to 2 root 2. So my output is irrational in the first case. My output is again irrational in the other case, where I am getting 2 root 2. 2 is a rational number, but root 2 is getting multiplied with it, so it becomes 2 root 2. See, when you have apple and apple, it becomes 2 apples. So this is 2 root 2. So this entire term becomes irrational. If I take root 5 plus minus root 2, again I will have to leave it as it is. This will be 5 minus root 2. So this term is irrational. How about negative sign? If I take root 2 minus root 3, it is going to give me an irrational number because this entire term is irrational. You can't add these two terms. These are both examples of even for that case, these both were irrational numbers. We have to take only rational and irrational numbers. So even if I say 5 plus root 5 or root 2, this is an irrational number, you can't add them. How about negative? If I have 2 minus root 2, this stays as it is and this is an irrational number. How about multiplication? If I take 3 into root 2, this is going to give me 3 root 2. So the output here is irrational again, because 3 is, although it is rational, it is getting multiplied with root 2. Therefore, this entire term becomes irrational. If I take something like 3 into root 3, it is going to give me 3 root 3. So even if I take any negative number, let's say minus 3 into root 5, this will be minus 3 root of 5. So the output here is irrational with the negative sign. For division, if I take something like 2 divided by root 3, you can't cancel. If I take 3 upon root 3, this can be further written as root 3 into root 3 upon root 3. So one of the root 3 will get cancelled, but my output here is root 3. So the root 3 again is an irrational number. So did you notice in this, when you take a combination of rational and irrational number, your output is always irrational. So what did you notice? when you take into consideration these 4 signs, which is addition, subtraction, multiplication and division, or the way I have written multiplication, division, addition and subtraction, if you take 2 rational numbers, the output is going to be rational. If you take 2 irrational numbers, the output could be rational or irrational, and when you take a combination of both, which is rational and irrational number, your output will always be an irrational number. So with this, we wind up with the explanation of your operations on real numbers. We will take a look at the solved examples in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.